Hey grade 9s. All right, let's do the next lesson here in our unit. I just want to make a quick note that there are actually a few more than 4 lessons after all in this unit. I decided to break some stuff up into a few pieces. So just like a heads up on that what I said in the first video about there only being 4 lessons isn't actually true. I think I ended up with 6 so they could stay a little bit shorter instead of having 4 kind of longer lessons. So anyways, just a heads up on that. All right, so last time we talked about central angles, and today we're going to talk about what's called an inscribed angle, okay? And an inscribed angle is a little bit different than a central angle because the vertex is on the edge of the circle, like you see here, instead of in the middle of the circle or at the center, like a central angle. Okay, and so we can see here in this diagram that that's an example of an inscribed angle, and then I'm just going to change colors here. This would be an example of a central angle. Okay, so the green one will be from last lesson, and the yellow one is today's lesson. Now, the important thing about inscribed angles is that they have half the measure of the corresponding central angle. Okay, that's the really important piece here, and that's what these notes are going to talk about. So, the measure of AOB, so here, that central angle, the green one, I'm going to highlight so that you can correspondingly see them in your notes, okay, is 2 times the measure of angle ACB. Okay, let's try and highlight that better. There we go. Okay, so if you take the measure of this angle and you multiply it by 2, that'll give you the measure of this angle. We can see that AOB is a central angle and ACB is an inscribed angle. And in both cases, the intercepted arc is, I'm going to use a third color here, okay, is arc AB. Okay, so they both share that intercepted arc, and we're going to see the importance of that quite a bit during this lesson. Okay, all right, so find the measure of each missing angle below. In this example or set of examples, we're going to be using the fact that we know that the central angle, so in this case this one, or in this example this one, okay, I'm not a great artist, we know this, but you get the idea, is exactly 2 times the measure of the inscribed angle. Okay, so if we have the inscribed angle here, and that's what we're trying to find the measure of, then we know that 50 is equal to 2 times the angle we're looking for. Okay, and so if we divide both sides by 2, then we can see that our angle, I'm going to call it angle question mark, okay, so that we can have a name, is equal to 25 degrees. Okay, and you don't have to show this work in this kind of question, but that's the logic behind it. And again, I just want to reiterate that the way we know that is because they share this intercepted arc. Then we know that this angle is exactly 2 times this angle, and that's from here. Okay. All right, so same logic here. We have, again, 2 angles sharing that intercepted arc, right? We have an inscribed and a central angle. And so if we know that this central angle is 130 from this, right? We talked about last lesson, again, a reminder that when you have a central angle, its measure is the same as its intercepted arc. And so since we've given you the intercepted arc measurement here, then you can also use that to find the angle measure of the central angle. And then from there, we know that this inscribed angle will be half of that. Okay, so we know that, I'm going to again call it angle question mark, is half of 130. Okay, so again, it's 2 times the angle question mark is equal to 130 is the other way to say that. And so when we divide by 2, then we're going to get that angle question mark is equal to 65 degrees. Okay, all right, moving down the page. Multiple angles can intercept the same arc, and then that means they all have the same measure. Okay, so in this diagram here, I'm going to just change again colors. We can see that this angle ADB and angle ACB and angle AEB all intercept that same arc right here, AB. Okay, and so because of that, we know that they have the same angle measurement, which is just what I wrote here. Okay, so they're all the same angle size. Now, using that, we can complete this example. So we're going to determine the measure of each angle if we know that the arc, which is marked in black, and I'm going to just highlight it here in case you're not sure where I'm looking at, is measured at 58 degrees. Okay, so if that's 58 degrees, then we know that angle blue, red, and green are all going to be half of that. So we know that blue is equal to green is equal to red in this example because they all share this intercepted arc. And so that means that they all are equal to half of angle 58. So 58 divided by 2 is equal to 29 degrees. Okay, moving on. Let's do a few more examples, then this lesson is already over. So most of these questions have a little mark indicating which angle we're looking for, but there are a couple that don't, so I'm just going to draw them in here. Okay, so we're looking for this angle here. Again, I'm going to call that angle question mark. You could call it X, it doesn't matter, just something to show which one we're looking for. Okay, so in this case, I've given you a little bit the opposite. Okay, so this time we have the inscribed angle, and we're looking for the central angle. And you can see again that they share that intercepted arc, so that means that we can use this rule. Okay, so if this is 37, then we know that this one will be twice as big. Okay, so angle question mark is equal to 2 times 37 degrees, right? Because it is twice as big. Okay. And yes, so then we are going to just multiply 37 by 2, okay? And I would prefer it if you guys didn't use your calculators, of course, but I know that you're at home, so you probably will, but these are good skills to have, just being able to do that sort of multiplication without a calculator. Okay, then the next one, same idea. We have an inscribed angle and a central angle that share this arc, right? So we can use our rule again. So the central angle, in this case, angle question mark is going to be 2 times the 41 degree angle, okay, the inscribed angle. And so when we multiply 41 by 2, we're going to get 82 degrees. Okay. Next one. Now these ones are going to look a little bit different, and that's okay. Okay, the rules still apply. In these cases, though, we may not always have the central angle drawn in, and so you're going to have to kind of use that logical reasoning that we've been talking about all year to figure it out. Okay, so in this case, we can see that this arc is 80 here. Okay, and that means that if there was a central angle drawn, okay, I'm going to try and draw that a little more accurately. There we go. Okay, sorry. Then we know that this would be 80 degrees. Okay, and so because of the fact that we know that the inscribed angle that goes with that central angle, so in this case, this one that we're looking at, this question mark, is going to be half of that, and then we know that angle question mark is equal to 40 degrees. Okay. Going across to E, we have the same logic, okay? And actually, it turns out we have the same number. It's totally a coincidence, so that was not on purpose, you guys. I just picked examples, okay? So again, we're going to pretend, oh, that's a bad line. We're going to pretend like we have a central angle here, right? We don't need the central angle for this to work, okay? But if we did have a central angle here, then we would know that this is also 80 degrees because its arc is, okay? And so then now, because we have this arc here that is shared between the central angle and the angle we're looking for, angle question mark, then we know that again angle question mark will be half of the central angle, and so that gives us 40 degrees. Okay, so yeah, again, inscribed angle, half of the central angle. All right, 2 more examples and then we're done for this lesson. So in this case, we're going kind of the other way, okay? So I'm going to just pick a new color here. We have, in this case, the inscribed angle, right? And we're looking for the arc. Okay, so remember that this whole thing is what we're looking for. And if I were to draw a central angle this time, it would look a little bit weird, okay? And that's okay. So if you wanted to draw this in, let's see if I can get this to look pretty good here. It's hard to use the stylus, you guys know that. Then it would look like this, okay? And so just by looking at this diagram here with our central angle kind of sketched in, it doesn't have to be perfectly accurate, that's fine. We can already see that this arc is going to be bigger than 180 degrees, right? We can see that's a major arc because it goes more than halfway around the circle. Okay, so that's our first clue. Now, the next thing is we know that if this inscribed angle relating to this intercepted arc is 95 degrees, then the central angle will be twice that, and that means the arc will also be twice that. Okay, so the measure of arc, question mark, remember that little symbol means arc, okay, is equal to, we're going to call this angle x, okay, is equal to angle x, and angle x is equal to 2 times angle RSQ, and we know that angle RSQ from the diagram is 95 degrees. Okay, so what we're saying is the measure of the arc we're looking for, remember that this M stands for measure, is equal to 2 times 95 degrees. Pardon me. And when you multiply that, again, would love it if you guys didn't use your calculators, but if you need to, it's okay to check. Then we're going to get 190 degrees. Okay, so there we go. And then last but not least, F is a little bit more complicated, which is why I left it till last. Okay, but that doesn't mean we can't do it. Okay, I believe in you guys. Oops, sorry. Let's zoom in a little bit. Okay, there we go. So if we know that this is a diameter, which it is, right? Because we can see it, this is a chord that goes through the middle of the circle to the other side. So that makes it a diameter. That means that that line, BD, is cutting the circle in half. So that means that this whole thing, this whole arc, has to add up to, do you remember what? 180 degrees. Okay, so I'm trying to draw this nicely, but it's like really not working. Okay, so that has to be 180 degrees. Alternately, we could write that over here, right? Arc BCD is equal to 180 degrees. Okay, so that's the first thing we know. The second thing we know is that we have this angle here, 46, right? And that corresponds with this portion of the arc, right? So here we go, okay? And we know then if this is an inscribed angle of 46, then, hang on one second, I'm just going to write this out. Since angle DB, oh, that doesn't look like any letters. Sorry, guys. DBC is equal to 46, then arc DC is equal to, do you remember what the rule is? Twice that, right? Okay, so that's going to give us 92 degrees, okay? And if this is true, if we have 92 degrees here, then we just need to find out what's left over from 180 to find arc question mark, okay? So we're saying that if we know this whole thing is 180, and now we have 92 of those degrees, we're going to subtract those to find the remainder, which is the arc that we're looking for, and that gives us 88 degrees. Okay? So arc question mark is equal to 88 degrees. Probably should have put boxes around my other answers as well. It's not a big deal if you didn't, though. Okay, so there we go. That's this lesson. We're going to go on to inscribed angles and quadrilaterals in the next video, but let's try the worksheet that goes with this video to begin with, and message me if you have any questions, as always. Okay, talk to you next time.